Well, welcome to today's stream. I am Isaac, and I'm part of Planetary Space Systems. Um, welcome. Sorry, I just had some technical difficulties there, but thank you for joining today's stream. I gotta update the clock countdown. We are currently, once it's 3:23, 1 hour and 35 minutes Eastern time. It's still 1:33 p.m. here. Well, thank you for joining me. Now SpaceFlight's live stream is gonna go live at 2. I'm gonna be sure not to be late for that. I'm just gonna edit the clock, and I'm gonna tell you about tell you some things about the launch. Okay, so we know one thing that's gonna happen on today's flight. Um, what we know is that, well, this is a rocket. This is going to be really hard to make, to produce. This is a small rocket, so it isn't as complicated. It's not going to be so much delays. And NASA Spaceflight is partnering with Astra for this live stream, and as the last one, it might go down as longest live stream ever happened in history. But thank you for joining. We're going to, so I know how much time it's going to be till 3:35, and then when I do the countdown, we'll start. But thank you for joining. This isn't an easy live stream to make. I had to cut some of my schedules, and I'm quarantined, so if I wasn't quarantined, I probably won't be live streaming this launch. Okay. Okay. Countdown has started. A little late there, but I'm sure when the NASA space light goes live, I'll make the clock go right. They're gonna go live soon, so I wouldn't worry. I'm gonna get some lunch, make lunch, lunch, but let's hope they're not eating lunch as well. But I'm gonna play some music and I'll be right back. Okay, well, T-minus 1 hour, they should be going live by now. Or my clock is 100% wrong. I would say that. Yeah, 100% wrong. I'm gonna fix that. Let me see. Get 70. Yeah, but then this should be going in like, oh, so 1 plus. So 70. I'm just gonna mute it and I'm just, I'm just gonna try to find some other music I'm gonna play. Okay, the clock is up and we're running. So now it's time for me to discuss about what's gonna happen on for today's launch. Well, this is Astra's not fifth attempt to get in orbit, but their fifth launch. The last 3 attempts were failures, but on November 12th, I think, 2021, it successfully went to orbit. And I'm happy because, like, that's basically when SpaceX, they had a lot of trouble with the Falcon 1. It took them 3 tries to get to orbit, and the 4th time's the charm now. if you want real life, then it's 3rd time, but if you want rocket science, luck, it's 4th time charm. But it can be different, like, I expect Firefly to get to orbit on the 2nd try. Yeah, it's pretty cool that there are new space companies going far of our solar system to explore Mars, explore the solar system, to explore, well, everywhere. It's just so cool that we are all living and seeing this. It's amazing. So, what do we expect on this launch? Well, we expect the rocket to go to orbit, of course, because if it doesn't go to orbit, then that's a failure. No shame on Astra. Orbit is hard, and it's not easy to get orbit. So, yeah. I'm trying to see what I'm trying to see about the Astra launch because oh yeah, here it is. Okay, so this is what we expect on today's launch. Well, it's expected to launch at 18 to 21 UTC or 13 to 16 EST military time. The mission name is ELaNa 41, Educational Launch of Nano Satellites 41, as a part of NASA's VCLS Demo 2 contract. The launch provider is Astra, the customer is paying is NASA, and the rocket is Rocket 3.3, the latest version of their rockets. 3.1, 3.2, 3.3. And this is LV008 or LV008. Launch location. This is gonna be the first launch from Florida. Unlike no other rocket from Astra launched from Florida. It's gonna launch from Space Launch Complex 46, Cape Canaveral Space Force Station, Florida, USA. Payload mass. It's just gonna go into Sun Synchronous orbit. No one knows what the payload mass is. Where is the payload going? To a 500-kilometer lower orbit, LEO, at a 41 inclination. They're not gonna cover this. The first stage will crash into the Atlantic Ocean, which means I can see it. Not, but please don't press on my building. So no, they're not gonna cover that. Fairings. The fairings are new, fairly. The Weber is currently 90% go for launch as of February 8th, so we don't know. This will be the first launch for Astra 2022, the first launch for Astra from SLC-46, the third commercial launch for Astra, the fifth launch of an Astra Rocket 3, and 12 orbital launch attempt of 2021. This will be, this is cool. The VCLS Demo 1 contracts are given to companies like Firefly Space Systems, which is now Firefly Aerospace, Rocket Lab, of course, why not, and Virgin Galactic. The VCLS Demo 2 contracts are for Astra, as we know it's going to launch today, Relativity Space Inc., which we know is 3D printing rockets, is really cool, and Firefly backed LLC. I don't know what that is, so. These satellites are they're from students all around the country. Not like students, like people in elementary, middle school, like people in high school or college. Those are not really engineering rockets, but your satellites will be put into space, which will be honestly cool. It will be amazing. Yeah. One of the satellites are VAMA 1. VAMA 1, designed and assembled by UA Space at the University of Alabama, is a free CubeSat weighing 2.5 kilograms. I don't know if that's heavy or not. I know what a gram is, but I know what a kilogram is, but that seems small for that much weight. It is a technology demonstration satellite. Upon release from LV008 second stage, VAMA 1 will deploy its 1mm drag sail made out of clear mire to drastically reduce the time to deorbit. It will be deployed out of the aft 1U section of the satellite using common materials that can be bought in any hardware shop. So I can make the sail better. So that's cool. That's good, I guess. I would love to show you the pics, but I don't want it a mega copyrighted, so I don't want to. You can go to Everyday Astronaut's website and check it out for yourself. The second satellite is INCA. INCA is the Ionospheric Neutron Continent Analyzer, INCA. It is a 3U CubeSat with a directional silicon photomultiplier SIPM based neutron detector that was developed by the University of New Hampshire and built by the NASA Goddard Space Flight Center. I think that's near me. That's cool. The goal of the scientific investigation mission is to gather data on the neuron. Is it neutron or neuron? I think it's neutron spectrum in low Earth orbit to improve space weather models and forecasts, as current data is limited to high-altitude balloons. Inca will be the first satellite in low Earth orbit with a neutron detector. That's honestly amazing. Like, wow. It's so cool. Like, it's just, I have no words for it. It's amazing. That's all I can say. It's just, wow. First, built by students. That's just mind blowing. And the third one is CubeSat. CubeSat is the only 2U CubeSat on the ELaNa 41 mission. It too was a technology demonstrator mission with the primary goal to test, qualify, and to see what effects low Earth orbit has on a quantum gyroscope. Developed by researchers at UC Berkeley, CubeSat will look into the application of a quantum gyroscope using nitrogen vacancy sensors in diamonds. Nitrogen vacancy sensors in diamonds are point defects where a carbon atom is substituted by a nitrogen atom, with another neighboring carbon atom missing in the structure of a diamond. This nitrogen vacancy sensor has measurable quantum properties, which makes it possible to form a gyroscope that measures angular momentum. This application is especially interesting as it can further downsize gyroscopes for use in the already small CubeSats. It's actually not that small as the other satellites that I've seen by the pictures, but it's actually kind of interesting. And the last and final satellite I think is R5S1. R5S1 is another 3U CubeSat on ELaNa 41, developed by NASA's Johnson Space Center, Houston. Its purpose is to demonstrate and validate fast and cost-effective to build CubeSats. Furthermore, it tries to demonstrate key technologies for space inspection, which could help to further improve safety on crewed space exploration. With its cost-effective approach, R5S1 can also demonstrate a cheaper way to test and validate technologies like high-performance computers, cameras, software, and a new communication method. This will honestly be really cool. This is the first launch that NASA asked, Astra to launch their satellite in space. This will be a cool one. NASA spaceflight is going live soon. They're going live in about 6 minutes, so I'm gonna play a 6-minute music video. Or I could just talk the whole entire way about what's gonna happen on today's flight. But yeah. Also today I actually watched something pretty weird. Something trended. It was like I saw this on Discord, and it said Mario takes your liver. I watched it. I regret it for my life now. I regret it. So if you want Mario to take your liver, yeah, this video. Can take it. Yeah. Well, anyways, let's continue. T-minus 5 minutes until NASA spaceflight goes live and my voice doesn't die off. Yeah. So what's gonna happen on today's flight? I already told that. If you're new here, you can just replay the video, the live stream in like a few minutes past back. That is when I explained what's gonna happen on today's flight, when it's gonna launch, and all those important, pretty needy details that you may want. Well, yeah. So okay, let's see the comments. Well, it says, yeah, I already replied to this stuff. Also, it says, Tokat. Hello from Russia. Nice to meet you. Aw, nice to meet you too. And I don't know how to say that name, but it seems like he or she, I don't know, is confused. If you're confused about today's flight, just go a few minutes back and you'll get all the info you need for Astra's launch today. 4 minutes until they go live, so I'm gonna just wait a few minutes and I'll be back when NASA Space Flight's about to be 1 minute until they go live. The time is done. NASA spaceflight will go down in history. They are going to go live in only a few. It's 2. It's time for day to go live. Just kidding, no. But they are going to go live soon. It says waiting for NASA spaceflight. I hope there's no delays or my life will be over because last time I was in so much stress. Never fine. But let's just wait and see this rocket go to space, because that's what rockets do. I like rockets. Rockets are good. They're good. They're good. Yeah. Well, so they're waiting for NASA space right now. It's already 59 minutes. They should be going live now. My mouth is frozen. They're supposed to go live anytime now. They're gonna go live anytime now. Oh, they're live. They're live. That's good. I'm gonna let the things.
Propulsion continues to be nominal.
The chamber pressure looks good.
Doubling up. Roger roll, ELaNa.
Water towers fly!
Yeah! Echo Delta nominal.
Fighting outside feed off. Bring in, feed off.
Yikes. You bet. Concur. We don't need any more of these.
Right. CubeSat. We don't need.
Hello and welcome everybody. You are looking live at Launch Vehicle 0008 on the pad in Cape Canaveral, Florida at Space Launch Complex 46. Astra is just under 60 minutes away from conducting a launch for NASA to deploy 4 CubeSat payloads into low Earth orbit on the NASA ELaNa 41 mission. This is the third launch attempt for Astra and Astra's first mission from Cape Canaveral. We are coming to you live today both from Cape Canaveral, Florida and Astra's headquarters in Alameda, California. My name is Thomas Burkhardt. I'm the news director for NASA Spaceflight, and I'm joined by Kerosene Grossman, Director of Product Management at Astra. Kerosene, thank you for joining me once again today.
Thanks for having me again, Thomas.
Always a pleasure. We will be bringing you this live coverage of today's mission as we have previously. Astra and NASA Spaceflight are once again partnering to bring this live cast to you, so thank you to Astra for partnering with us to make that happen. And also, as usual, we will be taking your questions throughout the course of the broadcast. So if you have a question about today's mission, please tag us with @NASA Spaceflight in the chat. We're going to be bringing those in through Michael's nifty software, and we'll be asking as many of those as we can throughout the course of the broadcast. Right now, we're at T-minus 57 minutes and counting, so Carolina, let's start off with a status update. What are the teams working on as we proceed towards liftoff?
Sure, Thomas. As you can see, that middle third of the rocket is a nice frosty white as propellant load is ongoing onto the vehicle, and all things are looking nominal. And you can see it's also a beautiful day in Cape Canaveral. We are not tracking any weather issues at this time, so we are going to proceed through our countdown with a T0 time in 56 minutes and 30 seconds.
The Space Launch Delta 45 and the 45th Weather Squadron predicted a greater than 90% chance of favorable weather today, and as you can see on your screen, that has definitely played out. Crystal clear skies, hoping for some amazing visuals from today's launch. Liftoff is also on track for the opening of today's window, which is 3 o'clock p.m. Eastern Time, which is again just about 56 minutes from now. And this mission is the first from Cape Canaveral for Astra. It's launching from Space Launch Complex 46, which is on the Cape Canaveral Space Force Station. On board this rocket are also the first satellites which Astra aims to deploy after a successful orbital launch. Those 4 payloads are part of NASA's ELaNa program, the Educational Launch of Nanosatellites program. The mission is designated ELaNa 41, also designated the VCLS Demo 2 mission for the Venture Class Launch Services program, which aims to provide dedicated launch services for small satellites like these CubeSats. 3 of the CubeSats are provided by different universities, the University of Alabama, Tuscaloosa, New Mexico State University, as well as California, Berkeley. And then the 4th payload is direct from the NASA Johnson Space Center. All 3 U-sized CubeSats on board. Those are the payloads on board Astra's first mission to deploy payloads into orbit, like I said. And as Carolina mentioned, no weather or technical issues right now. The countdown is proceeding. Over the course of the broadcast, we'll also keep you updated how that countdown is proceeding with any updates as needed. This mission does build off of the first successful orbital launch from Astra, which was the LV007 test flight out of Kodiak Island, Alaska. And let's take a look at a quick recap, which shows how Astra got to today.
10, 9, 8, 7, 6, 5, 4, 3, First motion. First motion. Vehicle is clear of the tower.
Aether confirms good startup.
Seco.
And Astra's LV007 has successfully reached orbit. There is a new orbital rocket. And we are now going to welcome a special guest to today's live coverage. Hemant Charazia is a Vice President of Product Management at Astra. Hemant, thank you so much for joining the live broadcast today.
Thanks so much, Thomas. It's great to be here.
So I want to talk to you a little bit about what you do at Astra and how you contribute to the team. So your role is Vice President of Product Management at Astra. What are your responsibilities in that role?
Yeah, great question. So I'm part of the product management team at Astra, and you've met Carolina Grossman, one of the stars of our team. Overall, the product management team is really all about answering the question of what is the right thing for Astra to build next. And that's based on understanding what the market is deeply, understanding what our customers need, and understanding what we can build. You can imagine that that's a very cross-functional activity, but fundamentally it's about charting that course forward and creating a few different things. One would be our North Star vision for the products that we're building and the roadmap of releases that in step-by-step get us there towards that North Star vision.
You mentioned this being sort of a cross, a cross kind of capability where you have to work with other people. Do you work closely with the engineering and operations teams when you're developing these new products?
Yeah, absolutely. Engineering and operations are two very, very critical elements of the company to engage with in answering these questions, but also so many others. I think of program management, I think of production, sales, mission management, finance, regulatory, spaceports. So many. There's a long list of internal and external stakeholders that every one of them has an important piece of the puzzle in understanding what is the right thing to build next that makes the most progress towards our
If
vision.
you are new to the
Well, when aiming to grow your teams in order to pursue that Astra's kind of overall overarching
if you
goal.
are new to the stream, well, welcome. It's about T-minus 50 minutes until this rocket gets off the pads and accomplishes orbit. Currently, they are talking about the vice president of sales at Astra. It's a very vital role, but honestly, it might be kind of boring for some viewers. But yeah, welcome to the stream. This is gonna be cool. So what? This rocket didn't accomplish orbit until like last year. Even this company has been founded for 5 years. Okay, let's just get this straight now. I don't put any backlash out for Astra. They are a great company, and I'm a Team Space, not Team SpaceX. So let's just. I'm just very surprised that I had the same timeline as the SpaceX Falcon 1. Yeah, that's cool. So let's go back to the stream. I'll see you later.
Is really the first of its kind. There are no other container shippable rockets, and what we're doing is a first in so many different ways. So everybody in the product team really has to be able to learn fast about new technologies, new markets, new types of businesses. And then the last thing I would say is ability to bring people together, ability to convene, to influence, to really align a broad cross-functional team around a vision for the product, a thing we're trying to do in the world, and then to ship that, to work together to bring that into reality. And so these 4 key skills are intrinsics we look for, and we have great people in our team right now. In terms of backgrounds, I would say that product managers in aerospace are a bit of a rare breed. It's not really a traditional role. So there isn't any cookie cutter formula for background. Certainly, people who have had product management experience at other companies that build mixed hardware and software products, they will have had an opportunity to build many of these intrinsic skills we're talking about. So that's a great background. But also, it doesn't have to be that. And also, it doesn't have to be any particular industry. At Astra today, we already have a very diverse range of backgrounds at Astra. People have come from automotive, from big tech, from aerospace, from all sorts of different industries, and we hugely value that. It's really an important part of the magic at Astra about building something that's fundamentally different as a new future for the space industry.
And so that team, which comes from all of those different diverse backgrounds and experiences, is all coming into Astra to achieve Astra's or aim towards Astra's long-term goal of improving life on Earth and from space. How does today's mission, the LV008 mission, and your work in the product management team work towards achieving that goal?
Yeah, great question. And I love this question. It can never be asked too many times. I think, big picture, a really important step in improving life on Earth from space is to develop the scientific understanding and the scalable technologies that we'll need to build something really useful in space, the next generation of space-based services. That's really what I see as the theme of today's mission in a few different ways. And the 4 satellites that we're launching today from 3 awesome university teams and NASA's Johnson Space Center. The way I look at it, the 4 satellites we're launching today advance 2 broad goals. The first one is to help scale up our use of space, and the second is to do that more sustainably. So on the first theme, this scaling up, the first one I'll highlight is the R5S1 mission from NASA Johnson Space Center. They're really demonstrating a faster and cheaper way to build CubeSats, and simultaneously testing out new ways to get better data on how satellites are operating on orbit. This is very useful diagnostic information for scaling things up. The second payload that fits in this sort of theme of scaling up is the CubeSat mission, with a Q, from the University of California, Berkeley. And they're testing out a new kind of quantum gyroscope. A gyroscope is a critical element of every satellite on orbit that helps the satellite understand where it's pointed and where it is. And making these, this quantum gyroscope is one potential path to smaller, lighter, and cheaper gyroscopes. That's another way to scale things up in space. Overall, these 2 give us new ways to make cheaper and more scaled satellites. On that second theme, though, on sustainability, I would say that the first one, the BAMA-1 mission from the University of Alabama, Tuscaloosa, will test a new drag sail, which is a bit like, you can think of it like a parachute in space. Now, to really improve life on Earth from space, we need to be able to safely operate thousands of satellites in low Earth orbit. And an important part of that is to be able to very reliably bring satellites down when they've either failed or otherwise reached the end of their life. A drag sail is one promising solution to that problem, part of the suite of solutions. And the BAMA-1 mission is taking a really important next step in the development of this technology. The final payload I'll highlight is the Inca mission from the New Mexico State University Las Cruces. They're using a neutron spectrometer to take a new kind of measurement of space weather, to better understand space weather and predict it. Now, maybe many people in our audience don't think about space weather every day. What this really is to recognize that our sun is a dynamic and powerful force that's constantly emitting a stream of high-energy particles towards the Earth. And that bombardment of the Earth creates a space version of weather that satellites need to fly through and operate in. Turns out that it's really important for satellites to account for this and for us to understand what they need to be designed for in terms of space weather. Just this week, for example, in the news, we saw a large number of satellites lost on orbit purely due to the impact of space weather. So what the Inca mission is doing is really on an important topic to understand and better predict space weather. I'd say as sort of a backdrop to all of this, there's something a bit here for Astra, which is the launch today is Astra's next step in expanding access to space. Why do we care about that? Well, this is exciting for us because easier access to space means more great student teams and researchers flight testing new technologies on orbit. It means more entrepreneurs building valuable space services on orbit. And it means more governments and institutions building systems that benefit everybody in the world from space. And I think from my own days as a student at MIT, I've seen firsthand how awesome the innovations can be driven by a team of students and researchers at a university lab. And but historically, it hasn't been very easy to get those things into space, to flight test them. And so that's why, for me, it's such a huge honor today to be watching us give an opportunity to fly payloads in space from these great student and researcher teams. And so I'm very excited to see them fly and to see Astra take its next step in expanding access to space.
Absolutely. Heyman, thank you so much for joining us. I've loved hearing all that insight into both today's mission and your role in the product management team. So thank you so much for taking some questions with us and hanging out.
Thanks so much, Thomas.
All right, let's go ahead and listen into activity on the countdown net as the countdown proceeds at T-minus 43 minutes and counting.
Okay, well, they're done talking. So this is I got nothing to say. Last time I scripted it because I was honestly expected, but I lost it. I lost it accidentally dealing with the script. Yeah, I don't know how I even stayed for 2 hours yesterday.
In AV1 manage polling, please toggle do both ground and guidance polling mode.
Toggling do both ground and guidance polling.
So, as I was saying,
And Tango, I'd like you to re-enable pump battery charging by going into machine pump battery 2 manage pump batteries and setting mode 3 reset machine.
okay,
Toggling 3 reset machine.
okay.
And then mode 1 charge pump batteries.
Toggling 1 charge pump batteries.
Okay. So, what I was going to say is that, well, this is the first launch that NASA asked Astra to give their payloads, actually students' payloads, into space. It's cool, because then they can lead to a lot of trust in the future.
So we just listened in on some countdown steps being proceeded. Again, everything on track right now. We're at just under 42 minutes and counting for today's launch. Again, targeted for 3 o'clock p.m. Eastern Time. Like we said, we want to take some questions from chat over the course of today's broadcast. So again, if you've got questions, tag us with @NASA Spaceflight, and we're going to be bringing a couple of those in, and we got a few of them here now. Keith is asking about the last launch that Astra conducted, the LV007 mission. What was the goal and achieved objectives of that mission, Carolina?
Yes, so the LV007 launch in November, we saw the video of it just a few minutes ago if you joined us at the beginning of the broadcast. That was our attempt to reach orbit. We have constantly been working towards that milestone, and LV007 successfully reached orbit with a test payload on board. And so that test payload on board LV007 was not deployed. So today's mission, LV008, represents a few firsts, one of them being that this is the first Astra mission with payloads that we will deploy into space, as you just heard a lot about these exciting CubeSats and the scientific investigations that they will conduct. And it's also our first launch out of Cape Canaveral. So it's a couple of historic firsts for Astra with today's launch, and we are very excited to see how it goes.
And a related question, Arda is asking if Astra can launch payloads into polar or retrograde orbits, and I believe that ties in directly with the launch site that's being used for any particular mission, right?
Right. So if you have been following us for a while, we have launched our previous rockets out of Kodiak, Alaska, the Pacific Spaceport Complex, Alaska, and that location, which is a very high latitude, is great for reaching high inclination orbits, including polar and SSO. So yes, we can reach polar orbits, and technically those retrograde would be, flying, launching against the direction of Earth's rotation. So there's nothing really to prevent us from doing that either. But we're focused on the objectives that our customers want to achieve, and a lot of that is driven by our launch location. So while our Kodiak launch site has been great at helping us reach high inclination orbits, this launch site in Cape Canaveral is really wonderful for reaching mid-inclination orbits, which are particularly important for things like communication and weather observation, where you can get more coverage over the middle portion of the globe.
Another launch site question here from Matt. Could Rocket 3 launch from a boat at sea?
That's a very interesting question. I'll talk a little bit more about our approach to our launch infrastructure. So everything that you see in front of you here can be shipped inside a shipping container. And so no launches at sea at this time, but it does make it very easy for us to set up and deploy a launch site. And even the rocket itself is 43 feet from tip to tail, so that fits inside a 45-foot shipping container, a bit snugly, but it is one of the key differences about Astra, where we can ship everything to the launch site, and really all we need when we get there is a concrete pad, an internet connection, and a fence to help keep the area safe.
And we have another question in chat asking about, again, kind of related to launch sites. A lot of launch site questions, which is good, because first launch from Cape Canaveral, it's on topic. Does each vehicle get built slightly differently according to where it's going to end up eventually launch from?
That's a great question. And no, that is one of the things that helps us on our path to scale and really improve life on Earth by improving access to launch. So the rockets are built as identically as possible. We may make small tweaks in between, because our objective is always to learn and improve our system. However, those at this point, those have been pretty minor, especially given the success of the LV007 launch back in November. So we do make the rockets identical. It doesn't matter where they are launching from. They are exactly the same. The only differences may be any changes in our communication systems to ensure compatibility with the specific range, and any special payload adapters that we need for that specific mission. Otherwise, it's the same rocket regardless of where we are launching from.
And looking at the launch site a little more closely here, we have a question that we should have known we were going to have, although this is an interesting interpretation of this question. What are the pylons that look like they'd attract lightning for? Well, you pretty much got halfway there. Actually, on this particular camera view, on the very left-hand side, you can see the bottom part of one of the lightning protection towers, and they are there, like you said, to attract lightning. It helps protect the rocket. Space Launch Complex 46 has two big prominent lightning towers seen here as well to help protect the rocket. But of course, this pad is actually built for rockets. It's one of the smaller pads at Cape Canaveral, but still built for rockets that were traditionally bigger than Rocket 3. So Rocket 3 is just barely poking up over the trees in this view. Even this pad makes Astra's rocket look small, because it's dedicated to those small satellites. Another question here, Paul asks, is what makes Astra different from its competitors? What strengths do they have that other providers maybe don't have?
That is a wonderful question. And Astra, our mission is to improve life on Earth from space, and the way that we're hoping to do that is by developing the
I just asked a question about the rocket engine. You can see it on NASA SpaceX video.
So in terms of responsiveness, what we were just talking about with our ground support equipment fitting in shipping containers, being easily able to set up and tear down a launch site in a matter of weeks or days, that's one of our key advantages. And the reason that that's important, as we mentioned, is that a lot of the orbital destinations that you can reach depend on where you can launch from. So being able to be mobile and agile helps us to provide customers with access to the locations they want. The system is also really set up by a very small team of folks on the ground and operated by a small team of mission control and support engineers in our facility, which allows us to be really nimble. And it's also been really helpful during the COVID-19 pandemic, where it's allowed us to remain as safe as possible and minimize our travel. And finally, on the affordability front, we take pride in using low-cost materials and trying to lower the cost of access to space with our vehicle. And I believe that Thomas, you had a tour with our facility with our head of production, and that's been an exciting thing to learn a little bit more about how we go through the steps to make our system as affordable and low cost as possible, including staying away from fancy materials like carbon fiber and composites, and using as much automation as we can across our system.
Yeah, Carolina, you set me up for a shameless plug here. If you have not seen the Rocket Factory tour with Bryson Gentile, who was the head higher up in the production side of things at Astra, who gave us NASA Spaceflight a tour of the Rocket Factory a little while ago. It is on the NASA Spaceflight channel. I highly recommend checking that out because it's a wonderful insight to how Astra is working to lower that cost through different means, because some companies are looking at reusable rockets and things like that as a means of cutting down price, where other companies such as Astra here, you're talking about ramping up production cadence of expendable rockets and simplifying the launch preparations and simplifying the manufacturing, the different materials you choose. Those are the kind of factors you're looking at to reduce launch prices, right?
Yes, exactly. That's right. We take a number of steps in order to make our system as cost effective as we possibly can, and hopefully our customers can take advantage of that and get more payloads to orbit.
And speaking of getting those payloads to orbit, we have a question from Redacted. I don't know if that's their actual name or if I just am not allowed to know the name, but we'll go with it. The question is, what's today's trajectory? Is it flying direct east or somewhere else? I believe we even have a graphic to show where the rocket will be headed, and there it is, right on cue.
Yes, so this is the trajectory that the rocket will follow. We'll be following sort of that middle area. Those blue lines are the NOTMARs, the notices to mariners, the area that boats will keep away from, and then the red area is sort of our safe area that we have cleared with the FAA. So after the rocket clears this trajectory, we'll be flying. Starting to swing around towards the south again, flying over Portugal, Spain, the Sahara Desert, Ethiopia. So we'll be hoping for a nominal trajectory as we launch out of Cape Canaveral.
And if you are down here in Florida along the Space Coast or even along the southeastern coast of Georgia and things like that, assuming the weather is clear where you are, it is very clear here at Cape Canaveral. Highly recommend taking a look at this launch because the weather does appear to be pretty favorable for launch viewing. It is a different rocket than the ones that normally come out of here at Cape Canaveral, so it might look a little bit different, but rocket engines are pretty bright and hopefully you'll be able to catch a view. If you're local to Cape Canaveral, highly recommend this spot here, NSF Stephen Marr out there in the field near Jetty Park, and that is for Complex 46, because that launch complex is actually on the southern tip of Cape Canaveral, pretty close to the Port Canaveral area. So highly recommend heading out here. 31 minutes from now, this launch will hopefully be taking place, and we'll put on a cool show for the Space Coast here in Florida. If you are not local here to the Space Coast, we are, of course, thank you for tuning into the webcast. Happy to provide you with the views of the launch of this way. And we have a question from Sean who asks, or excuse me, I'm reading the wrong thing. Different question from K2K81. I don't know what that means, but thank you for your question. Are there any cameras on board the rocket? And if Michael gets that cue, he's going to show one of those cameras. There we go. Carolina, what are we looking at on these views?
Sure. So you are looking at the upper stage of LV008. So that the sort of top right-hand side of your screen, that is the fairing, and we will hopefully see very shortly after main engine cutoff, we will have stage separation and fairing separation, and those fairings will pop open and we'll have a beautiful view of Earth as the upper stage ignites to complete the final leg of the mission. And then this is a view looking upwards at our payloads. So we'll be tracking them as they deploy after SECO, or second engine cutoff.
Love seeing those onboard views. We're hoping to keep those throughout the course of the broadcast and show those as much as we can. We've also got these ground cameras, of course, and with perfect visibility, hopefully we'll get some good views from them as well. I do have a question from Planetary Space, which is talking about the most recent abort and scrub. If you tuned in earlier, this is not the first launch attempt, like we said. This is the third attempt for this particular mission. And last time there was that scrub due to that telemetry issue that the teams had to stand down to resolve prior to coming back today. But we saw that abort happen right at engine ignition. So the question is, what do the teams have to kind of work through when you light a rocket engine and then scrub? Could the engine be damaged from an abort like that, or other systems that have to be inspected and things?
Sure. So first, to speak a little bit about the abort that happened on Monday.
Oh my God! You answered my question. Okay, I'm gonna listen in.
Detecting latency in our internal telemetry communication, and it was a bit longer than we typically experience. We determined that it was unlikely to have impacted flight, but felt that it needed further review. And after this review, the team was able to identify the probable cause and potential effects, and run some simulations to determine that an impact to flight was unlikely, and also test some adjustments to improve the latency of the system in preparation for our launch attempt today. So we believe we have solved that issue. And now, more directly to the question, our system is actually designed for multiple ignition events. So we complete a static fire of the vehicle. It's our last major test of the full system. Essentially, we run through our entire countdown procedure, load propellants, light the engines, and run them for a few seconds, and essentially do everything except actually release the rocket. So we do design the system to be able to complete multiple ignition attempts, multiple launch attempts without damage or issue.
Excellent. We're actually hearing that teams are getting into final software config loads now, so let's go back in and listen to the countdown net as those steps are completed at 27 minutes and counting.
Victor 1-5 on engine Alpha. Good load.
Engine Bravo, 175, Victor 15.
Loading config 175, Victor 15 on engine Bravo. Good load.
Engine Charlie, 176, Victor 15.
Loading config 176, Victor 15 on engine Charlie. Good load.
Engine Delta, 177, Victor 15.
Loading config 177, Victor 15, engine Delta. Good load.
Engine Echo, 178, Victor 17.
Loading config 178, Victor 17 on engine Echo. Good load.
Aether, please provide an updated late load config if you have one.
Aether late load config 183, Victor 8.
Loading config 183, Victor 8 on Aether. Good load.
GNC, do we have a late load config?
Yes. 5 Victor 148.
Loading config 5 Victor 148 on guidance. Good load.
Tango in VB1, turn on off PDBs. Please run a GNC setup. GNC, call out when complete.
Toggling GNC setup.
So as you just heard, teams are working on those final software loads, and those are going well. T-minus 25 minutes and counting, all on track so far. So we'll keep some questions coming, and the liftoff is still targeted for the opening of the window at 3 o'clock p.m. Eastern. This question from Sean for ELaNa: how big is the launch window today, should any issues have to come up?
Right, that's a great question. We have a 1-hour launch window today. So our launch window extends from 12 p.m. Pacific 1 to 1 p.m. Pacific. I am blanking on my UTC math at the moment, but we do have a 60-minute launch window. If we encounter an abort or an issue, our recycle time is typically around 15 minutes once that issue is resolved, so there is a possibility that we would be able to try again in the event of an abort. But again, everything looks nominal at the moment, so we are not anticipating any issues at this time.
If I use the time you took to answer that question to do some math in my head, I think that translates to 2000 UTC to 2100 UTC for those of us watching, or those of you watching from across the globe. Thanks for tuning in, and that is our launch window for today. I have another question here from Santosh, who asks, what engine does the rocket use? And I'll just expand that really quick because I believe we have a cool view of all the different components of this rocket. ELaNa, want to run us through what makes up a Rocket 3 from Astra?
Sure. So on the left side of your screen, you can see the expanded view of our rocket. We'll start from the left. That is the engine bay. You can see 3 out of our 5 first stage engines, the Delphin engines. They are electric pump-fed engines, each producing a thrust of 6,500 pounds for a total of 32,500 pounds of thrust on the first stage. The next large section is the first stage tanks. And those are filled with LOX and kerosene, liquid oxygen and kerosene, which are our propellants for both stages of the vehicle. The next section is our inner stage, which houses the large portion of the upper stage and our avionics system. Then further right, we have those 2 spherical tanks and the smaller engine with the long nozzle extension. That is our upper stage. Again, the upper stage is filled with LOX and kerosene, just like the first stage, and we have 1 pressure-fed Aether engine, which produces 740 pounds of thrust. And then finally, you see those 2 split halves of the fairing. And on top, we have of the upper stage, you can see an example of a CubeSat payload. Again, today it represents Astra's first mission deploying customer payloads into orbit, so we will be keeping an eye for that fairing separation and the payload deployment at the end of our mission.
Awesome. Chat, please keep the questions coming. If you've got a question, tag us with @NASA Spaceflight. That'll help us see your questions, and we're going to keep asking those as we get further into the countdown here. The current time is T-minus 22 minutes and counting, and all systems are nominal. Let's listen in to the activity on the countdown net as the teams continue to prepare for liftoff in just under 22 minutes.
If you didn't listen into the live stream, they literally answered my question. That's the first time they did. My question was last time they scrubbed and right after ignition, and I was wondering if that would damage the engines. The answer to my question is, this is not the full answer, but I think what they said is that when they do stuff like that, they simulate the rocket again, flight, and make sure it is go. If any maintenance is needed, they will go out to the pad and maintain it, or they'll put it back into their, where they build the rockets, which is going to take longer than I expected, but so I expect they did it on the pad, or just everything was go, which it was, and I noticed, so don't go in a chat and said, oh, you're so dumb. I noticed their rocket engines can breathe light. I noticed that. What have I been doing in the space tweet if I didn't know that? Like, how did SpaceX land a rocket engine? Like, it's not a solid rocket booster. This is one big real rocket. So, yeah. Let's go back to mission control.
Toggling spark now. Toggling off spark.
Delphin, please confirm results of spark test.
Delphin confirms good spark.
Copy, thank you.
And you just heard a good spark test, so igniter tests have been completed and the countdown steps are proceeding nominally. We're just about to cross T-minus 19 minutes and counting. Everything going well so far. What you were listening there was the mission control teams in Alameda, California working through those countdown steps. And ELaNa, can you walk us through who those team members are and their various responsibilities today?
Sure. So we just have this graphic that has popped up with their names. We'll start from the top left today. So we have Rose Jornales, who's our flight safety. The flight safety officer is responsible for making sure that we are following our trajectory. Then Christopher Rossi is our GNC guidance, navigation, control, or trajectory. So he's the one who is keeping an eye on our winds and making sure that we are safe to launch and follow our planned path. Claire Gauthier is our vehicle controller, who with the call sign of Tango, and she is the one who is doing the steps to load the software on the vehicle. She's the one who is the operator of our launch system. Chris May is our command and data handling, or CDH, and he's responsible for monitoring and adjusting any of our state machines which operate our system. Hill Hudson is our Flight Activities Officer, or FAO, and he's responsible for documenting the completion of our procedure. Chris Hoffman is our Flight Director, who oversees and directs launch vehicle operations following the countdown manual, and he can call hold, recycle, or abort as required. And then we don't have a tag for Eric Steinberg, known as Steiny, who is our IT and network point person. You may also hear, as we move through the countdown, the go no go poll, which is coming shortly. We have what we call the engineering backroom.
We're so close to launch.
Systems on the vehicle and our ground support equipment, who are distributed throughout our factory floor at their desks and monitoring all of their systems there.
In addition to those teams at Alameda, there's another team out in Cape Canaveral, code known as the Red Team. And can you tell us a little bit about who's out there for us?
Yes, we have a very small and nimble team known as the Red Team out at Cape Canaveral. They're the ones who set up the launch site, do any work required to configure the vehicle and the ground support equipment for flight. We are very grateful for them and hope they're enjoying the beautiful Florida weather, which is much nicer than it would be in Kodiak this time of year. We have Ryan Hirschfeld, our safety officer. Adam Frisch is our red lead. Robert Freeman, Eric Larson, Sam Hirschap, Benjamin Whelan, Rusty Haller are our red team. And then we also have, in addition to Steiny on our network and IT, we have Thomas Cannon as well. So all of 6 members of the red team we're very grateful for all of the work that they do on the ground at our launch site. They are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. And thank you all. Huge shout out to you.
For sure. Right now, 15.5 minutes to go. Again, everything on track so far. At the T-minus 15-minute mark, there will be the entering of terminal count. And that is going to be a big milestone. There'll be some other steps right after that as the teams get into that terminal count, followed by a go, no-go poll just over 10 minutes to go in the countdown. So let's go ahead, listen into the countdown net. We should have a water test incoming and then entering terminal count.
Takes us into Astra terminal count at this time, step 142. Tango, confirm that in AV1 managed power systems, we are in ground power system authority.
We are extremely close to lift off of this launch vehicle. Now it's the go, no go poll, so let's go back to mission control.
Running GNC self-test.
We'll go. GNC self-test passed.
Copy. Astra Safety, confirm that FTS is still enabled and nominal in the vehicle.
Safety can confirm.
Tango.
As the teams get into terminal count here, let's take a look at the mission timeline of all the events we'll expect to see after liftoff. Carolina?
Sure. Well, before liftoff, just a few seconds before, the 5 first stage Delphin engines will light, and at T0, if all of the checks pass, we will have liftoff. The hold down mechanisms will release the vehicle, and we will be at the beginning of our journey. Just a few seconds in, we'll begin our pitch over maneuver and expect to reach max Q at around 1 minute and 10 seconds. That's the point of maximum aerodynamic stress on the vehicle, and a significant milestone to hit in first stage flight. Then a few things happen in pretty quick succession. At 2 minutes and 50 seconds, we'll have main engine cutoff, or MECO, then fairing separation and stage separation, right before the upper stage Aether engine ignites at 3 minutes and 5 seconds. The Aether engine will burn for about 5.5 minutes before second engine cutoff, or SECO, at 8 minutes and 30 seconds. And then at 8 minutes and 40 seconds, we will begin our payload deployment of our 4 CubeSats, which will be deployed within a few seconds of one another, and we are hoping to get a good view of from our onboard cameras. And if we have completed all of those steps, we will have achieved mission success, and we'll consider today a very good day.
All right, let's listen back into the countdown net. We're coming up on that go, no-go poll, which is where Chris Hoffman will poll the rest of the team for their readiness for launch, and hopefully we'll get a go condition to proceed with launch in just over 11 minutes. So let's listen in.
Toggling off chill, toggling off load first, toggling off load upper, deactivating aux4 operate.
Deactivate aux1 OV201 first fill.
Deactivating aux1 OV201 first fill.
aux1 OV401 fill.
Deactivating aux1 OV401 fill.
Deactivate aux1 OV301 upper fill.
Deactivating aux1 OV301 upper fill.
In fuel 4 operate, please toggle off first and full.
Toggling off first, toggling off full.
Please deactivate fuel 4 operate.
Deactivating fuel 4 operate.
Deactivate fuel 3 supply.
Deactivating fuel 3 supply.
Fuel 1 FV300 upper fill.
Deactivating fuel 1 FV300 upper fill.
Fuel 1 FV200 first fill.
Deactivating Fuel 1 FV200 first fill.
Deactivate AV1 radios.
Deactivating AV1 radios.
And AV1 rocket support cart.
Deactivating AV1 rocket support cart.
Please confirm zero stop purging is still enabled.
Confirmed.
AV1 manage polling.
Confirmed.
AV1 manage power systems.
Confirmed.
The helium stack.
Confirmed.
Please activate Igniter 1 spark test.
Activating Igniter 1 spark test.
Please confirm VB1 first stage power is active.
Confirmed.
VB1 upper stage power.
Confirmed.
VB1 turn on off PDBs.
Confirmed.
Water 1 water system.
Confirmed.
Tango, please activate launch machine.
Activating launch machine.
With launch activated, please toggle locks topping.
Toggling on locks topping.
Okay, team, this brings us to step 151. Poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. That is a hold, hold, hold over the net. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Dolphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
CDH is go.
Tango.
Tango is go.
Safety.
Safety is go.
Flight is go. Tango and AV1 manage polling. Please toggle do only ground.
Toggling do only ground polling.
And let me know when you're ready to load flight engine sequences.
Ready.
Delphin, please provide.
Igniter sequence is 703 Victor 3.
Loading sequence 703 Victor 3 on igniter. Good load.
Engine alpha is 860 Victor 1.
Loading sequence 860 Victor 1 on engine alpha. Good load.
Engine Bravo 861 Victor 1.
Loading sequence 861 Victor 1 on engine Bravo. Good load.
Engine Charlie 862 Victor 1.
Loading sequence 862 Victor 1 on engine Charlie. Good load.
Engine Delta 863 Victor 1.
Loading sequence 863 Victor 1 on engine Delta. Good load.
Engine Echo 864 Victor 1.
Loading sequence 864 Victor 1 on engine Echo. Good load.
Ether, what can we load for you?
Ether sequence today 842 Victor 3, please.
Loading sequence 842 Victor 3. Rinse and repeat on Ether. Good load.
Tango and AV1 manage polling. Set us back into do both ground and guidance polling mode.
Toggling.
Alright, you just heard the teams have pulled go for launch and are into the final steps before liftoff. Carolina, this mission is about to lift off. What is the purpose of this mission? One more for people who are just joining us.
If you are just joining us, Astra is looking to deploy 4 CubeSats on this mission. Bama 1 from the University of Alabama, Tuscaloosa, demonstrating a drag sail module that will rapidly deorbit the satellite. Inca, ionospheric neutron content analyzer from New Mexico State University, Las Cruces, which is a scientific investigation mission studying the neutron spectrum in low Earth orbit for the first time. CubeSat from University of California, Berkeley, a technology demonstration to test and characterize the effect of space condition on quantum gyroscopes using nitrogen vacancy centers in diamond. And R5S1 from NASA's Johnson Space Center, Houston, demonstrating a fast and cost-effective way to build successful CubeSats. These are being launched on the ELaNa 41 mission, which is selected through NASA's CubeSat Launch Initiative and provided under a Venture Class Launch Services Demonstration 2 contract, which provides dedicated launch capabilities for smaller launch payloads awarded by NASA's Launch Services Program. So we are very thankful to our partners at NASA for providing us the opportunity to complete this mission for our 4 CubeSat payloads.
Coming up on T-minus 5 minutes and counting, we're going to go ahead and listen back into the teams as they work through the final minutes of this countdown. And we'll be looking forward to a liftoff.
T-minus 4 minutes until this rocket goes to space. Yes, actually better orbit. This is going to be a one-of-a-kind launch. I am so happy for you, Rocket 3.3. You get to fly again. It's not reasonable. I mean, like, this kind of rocket gets to fight. I am so happy for you. Let's see you get to orbit. I'm gonna just get the comms to mission control.
Reminder to all that any 3-word hold from here on out will be an immediate abort, regardless of source.
You can see the crew at our Astra headquarters gathering to watch the launch. I'm very jealous of Thomas, who will be stepping away from his desk for a moment and hopefully watching our launch in person. Got a nice crowd of spectators over at Jetty Park as well, hoping for a nice view of LV006. Excuse me, LV008. 3 minutes and 30 seconds.
Rock, this is flight on countdown. Please confirm range is recording telemetry at this time.
Confirmed.
Control room, if you require RF data in flight, be prepared to switch over your pages. MIFCO, flight on countdown.
MIFCO.
MIFCO, prepare to issue option when rocket IIP marker passes min-MECO point and is within dispersed trajectories, calling out at event.
MIFCO copies.
Two minutes and 30 seconds until T0 of the ELaNa 41 mission.
Masters enable, watchdogs enable.
Copy, thank you. "90 seconds. ACE at this time, start PSD recordings and downrange ground station recordings.
Good work.
"60 seconds, vehicles on internal power.
Godspeed, Astra, and good luck, LV008.
PSD recordings enabled.
45, first stage coming up to liftoff pressures. Tanks are pressurized at this time. 30 seconds. 20, 15, 10, 9,
8,
8,
7,
7,
6,
6,
5,
5,
4,
4,
3,
3,
2,
2,
1.
0.
LV008 has launched and is on its way to space. You can follow the flight milestones on the left side of your screen, as well as the velocity and altitude of the vehicle. Our next objective is max Q.
The next objective of the rocket I'm very scared for the rock. Oh my god. It lifted off! I close to orbit. Nothing goes wrong.
Should have passed through max Q. All systems on the vehicle are nominal.
They should have went to
We are tracking it down.
should have went to max Q now. Better increase your now.
We'll be looking for MECO or main engine
Next is
cutoff
main engine.
at T plus 2 minutes and 50 seconds.
Okay, oh my god, this is gonna be okay. Next is main engine cutoff and then station.
Clear skies have provided a great view of LV008 so far.
I'm so scared. I'm so scared. Wow, this rocket is going. Just so cool. We're supposed to expect about now. Engine cutoff. I think that's all. Oh, 9 kilometers. That's gonna be going fast. Not as fast. We're just going to mission control right.
Flight, MIFCO, option sent.
Copy.
FTS confirms option detected.
Safety can't confirm.
That call out of the option means that the system will safely be able to ignite the upper stage after
MECO.
our stage separation. And that was MECO or main engine cutoff.
We have MECO. That's cool. Oh. Bearings? Yep.
That was fairing separation and stage separation. And you can see that the upper stage Aether engine
running.
has lit.
No. Uh-oh. That's not good. That's not good. That's not good at all. Oh, no, that's not good.
Opening FV200A, opening FV300A.
That's not good. That's not good. That's not good. That's the FTS. That's the FTS.
Opening OV202.
Oh, that's not good. Oh, no, that was so close. Oh, that was a pain in the butt. Oh, that didn't work. Oh. Well,
looks like we've lost video of the upper stage and standing by for more information.
We know already it didn't work. Oh man, that's just a big fat boomer. Oh, so close. That's just a big boomer. Ha. So there's no use watching this live stream anyways now. But as you may have seen, that was an anomaly on the second stage. It appears that gimbal wasn't activated. It's either that or I went crazy. That was upsetting. That was a big fat boomer. Why? Why? Just why? That's gonna hurt. That's gonna hurt. There's already enough delays with the stock, with the rocket. That's gonna hurt the stock. That's gonna hit the stock. Oh, that's so bad. Well, as you may have just saw, that was an anomaly on the second stage of the rocket. Oof, that was a pain in the butt. Yeah. This control isn't saying anything. Last thing I heard is that, yeah, it isn't good. It isn't good at all. No! What happened? Oh man, that was good. If you just joined us, what happened is that the rocket had an anomaly. The second stage, I think gimbal was not turned on the rocket, or they separated the second stage. You're supposed to separate the families first, then separate the second stage, but instead it was the other way around. So that messed up a lot bit. The thing was open on today's test flight. It's not good for the stock of the company. They're probably, yeah, it's not going to be good. Probably going to decrease their money is already almost out, but that I just I was wishing it was absolute, but it didn't. It just didn't work, which is really sad. Yeah, that does. That was bad. I feel sad. Oh, so close. And you just getting it. It's really sad that it happened again. It happened again. It even reached space, which is really bad. Even after just rocket control wasn't on the whole rocket because I did see it kind of tumble a little. I think that moved second stage engine and when during separation, rocket basically was in a position that made it go out. You know those words, securing the area. You just heard that. They said it, securing the area, and that is bad. That's not good. Well, yeah. Yeah, someone said check your staging. That is correct. You have to check it. You did it wrong. Sorry, Astra, but you failed today. That is failure of today's mission. I am honestly very sad. It's sad because rocket company failed. Yeah, I'm not trying to focus on the failures, but like it's unbelievable. It's unbelievable, and it's still super sad if you're a space level. No one wants it. It's not good. It's painful. It's sad. I'm litigating to see tears in. I just feel bad for everybody who put their blood, sweat, and tears into today's launch. Everybody at Astra, we give our condolences to you. We feel sad for you and respect your hard work. Respect what you have done today for you. I would have played the mission control, but it seems like they're all pretty sad. Like they're all quiet for a while. Chad's going to go first. There. Space is hard. I feel bad for you. I also feel bad for the kid, for the student at universities like that. Rocket didn't work. What if they wanted the satellite? Didn't. Just heartbreaking for the engineers. Everybody working at at Astra and the people who made this happen. I feel bad. It's not possible. It's sad. I'm just gonna go chat and comments. I'm just gonna listen to the people.
And thank you for standing by with us. Unfortunately, we heard that an issue has been experienced during flight that prevented the delivery of our customer payloads to orbit today. We are deeply sorry to our customers, NASA, the University of Alabama, the University of New Mexico, and the University of California, Berkeley. More information will be provided as we complete a data review, and you can follow along for updates on Twitter at Astra, as well as on our website, astra.com.
Yeah, everyone, thank you for tuning in for today's live coverage, and thank you to Astra for partnering with NASA Spaceflight and allowing us to broadcast this launch to everybody. And again, stay tuned for further updates from Astra and from NASA Spaceflight. But thank you all so much for watching, and stay tuned for more information. But we'll see you later. Thanks, everybody.
Propulsion continues to be normal.
RCP chamber pressure looks good. Toggling up. Roger roll, ELaNa.
Water towers can fly!
Yeah! Echo Delta nominal.
Body down, feet off. Bring in, let's see, off.
Yikes. You bet. Concur. We don't need any more of these.
Yeah, that's a pretty sad ending to today's launch. No one expected it. It's not that no one wanted it. No one that it's just hard to think about this, that they failed for the fifth. Actually, this is the fourth time they failed. It's the fifth flight. It's just so sad to see this happen again. No one wants it. So I'll give all my condolences to the Astra team and students who made these satellites. Give our condolences and our love. We thank you for trying. Just don't give up, and we are all sure that you will make it next time. Thank you to my viewers watching today's live stream. It's a very sad live stream, but yeah, you have to accept life sometimes. There are challenges to take across the way to go to success, and that's what Astra experienced on today's flight. At Astra, hope Astra can get it on the next flight. And yeah, I don't say it correctly, but all I know is at Astra, and see you on the next attempt for Astra. And as always, space and peace out. I'll see you on the next one.